In this video, we're going to talk about classes, and I'll show you how to write a class so that you can create your own objects in a program. But first, I want to make sure that you understand what we're talking about when we talk about objects. Objects are resources that help a program perform specific tasks. When a program needs to use a particular type of object, it creates that object in memory. Now, you've already had some experience working with objects. You've used various objects in some of the programs that you've written so far. For example, you've used lists. A list is an object, and here's an example of a statement that creates a list. The name of the list is my list, and you can see that it stores 5 different elements, 5 items of data. Another type of object that you've worked with are dictionaries. Here's an example of a statement that creates a dictionary. The name of the dictionary is phone book, and you can see that it's initialized with 3 elements. These are names and corresponding phone numbers. And then another type of object that you've worked with are sets. Here's an example. This statement creates a set named my set, and we're initializing it with 5 different items. So lists, dictionaries, and sets are all examples of objects that you have used so far, and you know that each of these is an object that serves a specific type of purpose. Now, each of these 3 types of objects store data, but each one is unique in certain characteristics. Each of these 3 types of objects give you different ways to access and work with the data that they contain. This statement illustrates another type of object that you should be familiar with. Here we are calling the open function to open a file named data.txt for the purpose of reading. Now, you might recall that the open function creates an object in memory known as a file object, and that file object is associated with the object that the function is opening. So in this case, we're opening data.txt, and we are creating in memory, we're creating a file object that is associated with that file. Now, the file object that is created in memory has the ability to perform operations on that file. So our program will use the file object to perform operations on the file. The open function, once it creates that object in memory, it will return a reference to that object. So in this case, we're assigning the reference to the input file variable. So after this statement executes, the input file variable will reference a file object that we can use to work with this data.txt file. Now, all of these examples that I've given you are meant to illustrate how objects are resources that a program uses to perform specific tasks. As we just saw, if we want to open a file to read data from the file, then we're going to create an object that can help us do that. Likewise, if we have a collection of data that we want to store in some object, then we have a number of different types of objects to choose from. We've got lists, we've got dictionaries, we have sets. Each of these gives us different unique abilities. So we simply pick the type of object that will work best for whatever situation that we are writing a program for. Well, all of the examples that we just looked at are examples of objects that are provided by the Python library. But you're not limited to just the objects that are provided by the Python library. You can actually design your own specialized objects. You can design objects to do anything, any task that you can imagine doing in code. Now, to design your own object, you have to write a class. A class is simply some Python code that describes an object. You can think of it as a blueprint. It's code that the Python interpreter uses to actually create a certain kind of object in memory. So that's what we're going to look at in the remainder of the video, how to write a class. Now here in the editor I have an example of a Python class, and this is actually an example that comes from your textbook. This is a class named coin. Now the purpose of the class is to create an object that simulates a coin that we can toss. So when you toss a coin, it lands either with heads up or tails up. So we're going to have an object that simulates that. Now when you look at a class, you'll notice that the class code is a set of functions. So here we have the beginning of the class. Okay, it starts with the keyword class followed by the name of the class, which is coin. And class names traditionally start with an uppercase character, by the way. So this is the header for the class, and then we have an indented block of code. So all of these indented statements, these are the statements that are in the class. And you'll see that we just have some comments and we have a bunch of functions. Now the functions that are part of a class, those are special types of functions that are known as methods. So when you hear the term method, we're talking about a function that is part of a class. So what's the difference between a method and just any old function? Well, a method is a function that is specifically designed to work on an instance of a class, or I can rephrase that to say it is a function that is specifically designed to work on an object. So in this case, inside the coin class, we have several methods, and each of these methods are designed to work on a coin object. Okay, now the methods that are in a class, they perform various operations, and one of the things that a method does is that it assigns data, it assigns values to data attributes. So an object has the ability to store data as well as perform operations through these methods. And the data that is stored in an object, we typically call that an attribute or a data attribute. So let's take a look at this specific coin class, and let's see what its data attributes are and what its methods are. So first you'll notice that we have we have these comments, and then we have a method named init, or really it's named underbar init underbar. Those underbars, those are underline characters. And this is a special name in Python. When you have a method with this name, this is a method that is executed automatically when an object of this class is created in memory. So in a program, when we create an object of the coin class, or when we create an instance of the coin class, as we say, then this init method will automatically execute as soon as that object is created. Now, keep in mind, and I mentioned this a moment ago, that methods are functions that work on an object. So you'll notice that the init method, as well as all of the other methods in the class, they all have a parameter named self. So the self parameter is a variable that references the object that the method is going to be working on. Okay, so this is how it works. When we create an object of the coin class, then the init method is automatically executed, and the self parameter references that object. Okay, so what does the init method do? Well, in this case, the init method creates a data attribute called side up. Now the notation here says self.side up. So that means that we have a variable named side up which is a member of the object referenced by self. In other words, self references some coin object in memory, and that object has a data attribute named side up. Now, the side up data attribute is really just a variable that references a string, and in this case the string is the word heads. So let's take a step back from all that and sort of put in a nutshell what this init method accomplishes. When we create a coin object, the init method executes and it assigns the string heads to the object's side up attribute. So this side up attribute is simply an attribute that tells us which side of the coin is facing up. Okay, so that's the first method, the init method. Now, the next method that we have in the coin class is named toss. And the purpose of the toss method is to simulate the tossing of the coin. Anytime that we want to toss a coin, an existing coin object, we want to simulate the tossing of that coin, we're going to call this method. And the method, and notice that it has a self parameter, so that parameter, whenever the method is called, it references a coin object. Inside the method, we have an if-else statement, and we simply generate a random integer in the range of 0 to 1, and if that random integer is 0, then the coin has landed heads up, but otherwise it's landed tails up. So we're going to use a simple random number to determine whether the coin is heads up or tails up. So all that this method does, if we take a step back from this, when we call the toss method, it will randomly assign either heads or tails to this coin object's side up data attribute. And then we have one more method called get side up, and this is simply a method that we're going to call to find out which side is up. When we call this method, it returns the value of self.sideUp. So once again, self references a particular coin object in memory, and this returns the value of that object's side up data attribute. So that's all of the coin class itself. So how do we create an object of the coin class? Well, let's look at the rest of the program. You'll notice that following the coin class we have a main function, and this main function is not in the coin class. This is just a regular function. And if you look down here at the end of the program, you can see that we have a call to the main function. So when we run this program, we immediately call the main function, and this is where things get started. So inside the main function we have this statement: my coin equal coin. So this expression, we have coin, that's the name of the class, followed by a set of parentheses. This expression creates a coin object in memory. And remember, when we create a coin object, the init method is automatically called. So the init method will initialize the coin object's side up attribute to heads. And then this expression returns a reference to that object, and we are assigning that reference to the myCoin variable. So in a nutshell, what this statement does is that it creates a coin object. That coin object's side up attribute is initialized at the value heads, and a reference to that object is assigned to myCoin. Now the next thing that we do is we're going to print that coin object's side up method. We want to prove to the world that coin is actually heads up. So we call the print function and we print this message: this side is up, and then we call myCoin.getSideUp. So the get side up method, as you'll recall, it returns a coin object's side up attribute. Now in this function call, or in this method call, we are calling myCoin.getSideUp. So what we're going to get is the SideUp attribute of the myCoin object, the object that myCoin references. So we know that this coin starts out with its heads side facing up. So we should see the message, this side is up, heads. Now we are going to toss the coin. So in this statement, we call myCoin.toss. So the myCoin.toss method randomly assigns heads or tails to the object's side up attribute. So after this statement has executed, the myCoin object's side up attribute will be randomly assigned either heads or tails. And then here in this statement, we're going to print the results of that. We're going to print the side that is up. This is the same statement we have up here. We just print this side is up, and then we call myCoin.getSideUp. Okay, well, let's try this program. Let's compile and execute. And you can see here that first heads is up, and then we toss the coin and we get tails up. So let's try it again. And this time, of course, heads is up, and when we toss the coin, we get heads up again. Now, this coin class is a very simple example of a class. I suggest that you continue reading in this chapter. There are other examples using this class where we demonstrate other capabilities of classes, and as you read in the chapter, you'll also see an example of a bank account class that simulates depositing money into a bank account and withdrawing money from the bank account. The textbook also shows examples of storing your own objects in lists and dictionaries, and even an example of serializing an object.